Hey guys, I'm Safin, and today I'll be covering package management on Debian-based systems as part of the Linux Visually series. So, let's just start with some basics. All programs on Linux systems are run from a file. Just like you have a .exe or executable files in Windows, Linux systems have files that can be executed to result in certain expected behavior. This means that every time you run Minecraft or your favorite text editing software, your computer actually goes inside your storage, finds the huge clusters of ones and zeros associated with the name Minecraft, and uses them as instructions for your computer on what to put on your screen. These instructions manipulate your hardware on your computer, like the CPU, GPU, and physical memory, all for this to happen. The cluster of ones and zeros I just mentioned fall into the category of executable binary files. Just like you can have files that simply contain human-readable text, files can also contain bytes, or groups of ones and zeros, that are machine-readable, and make sense to the computer when it's trying to perform some action, like running Minecraft. A large majority of these files are stored by convention under the /bin and /sbin directories, as well as their /user counterparts. I'm going to go ahead and switch over to my image real quick and give you a quick demo. I'd also encourage you guys to do the same. If you just head over to /bin and hit ls, you'll see a bunch of these different files that correspond to executables on your system. For example, the which command is a command that you can just simply run like this, and it doesn't actually give you results. However, it is an executable that is stored in /bin. You can also check out /sbin, which has similar executables, as well as their /user counterparts. Alright, so these directories, or there also exist files under the etc directory, which are human readable and are meant to configure specific behavior of a program after it gets started. This is called runtime configuration, as opposed to compile time configuration, which is set in stone when the computer turns human readable code into machine readable binaries in a process called compilation. These files can do, and they can just do about anything, like set your render distance in Minecraft so that it stays the same as what you configure it to when you reopen the program. Some of you who are more familiar with computer hardware may be asking why these preferences aren't stored in your random access memory. This is because RAM is meant for temporarily storing or temporarily remembering information as opposed to long-term storage, which is why you have a hard drive or SSD. Now that we understand the main way that executables are stored and configured on a system, we need to understand how they get there. On Ubuntu systems, Minecraft isn't actually installed there by default. Rather, we make use of a package manager to perform the installation. Think of a package manager like an app store where we can download just about any app we want as long as the app store actually has it. Instead of apps, we'll refer to the group that encompasses a binary executable and its configuration as a package. A package contains the actual file containing the program along with some configuration for it, whether that be a file that allows you to set runtime preferences for that program, or perhaps even a PAM module that gets automatically generated for the program to function. Before we go on, we must make the distinction between two tools we commonly see being used to manage packages on Debian-based distributions of Ubuntu, namely dpackage and apt. Please note that in this video, I'm assuming you have a bit of background knowledge on how to use the apt command line tool to install, remove, and upgrade packages. If not, please pause the video and do a little bit of research on that since there's lots of great resources for it out there. You can think of dpackage and apt as two teams in a warehouse organization, one in charge of delivering boxes to a facility and another in charge of packing and unpacking boxes delivered to it and distributing their contents to the facility. Team Warehouse's sole responsibility is to manage boxes it receives, whereas Team Delivery's sole responsibility is to retrieve boxes from the outside sources and provide them to Team Warehouse in order to unpack them and use them as they wish. This relationship is parallel to the one between dpackage and apt. Dpackage is simply in charge of unpacking packages and distributing their contents amongst the system, whereas apt is in charge of retrieving packages from outside sources and handing them off to dpackage to manage. Apt cannot work without dpackage, whereas dpackage could technically function by itself, as long as there was a way to retrieve packages to be installed. Here's a simple experiment you can run in your terminal to convince yourself that this is truly the case. I've linked the packages.ubuntu.com page from which you can download the .deb file containing the SL package, and that's this link right here. I'm just going to go ahead and open this link in a new tab, and then I'll copy it and paste it into my virtual machine. Alright, so now that I've got to this page, I'm going to look for the architecture that I want to download the package for. In this case, it's AMD 64. And I'll just pick about any mirror that I'd like to download it from. I'll just go ahead and allow this download, and I'll head over to my downloads folder. Now you should see this sl something.deb file pop up, and now that we've seen this file, I kind of want to explain about what it really is. Now, this .deb file is simply just an archive similar to zips that contain all files corresponding to a particular program. This collection of files is what really makes up the package. Now, once I've downloaded the file, you can simply run dpackage-i, and I'd encourage you to follow along with this and do this on your own system as well. You can run dpackage-i followed by the name of the file containing the package. And I'm just going to hit tab to autocomplete. Whoops, hit enter. And you'll see that there's an error because it requires super user privilege, so you'll just rerun that with sudo. And there we go. Now we can run the SL command in our terminal, and we'll see a nice steam locomotive moving along. Now, obviously, although this works, it isn't necessarily practical. I should be able to download programs from the internet without having to search them up in my browser, without having to access the link on the internet. And there's a way to do that using the apt command. Now, this is where the idea of package repositories come in. Repositories are sort of groups of packages that exist on the internet on a central HTTP server. If you're not familiar with HTTP, this server is simply a way to download packages from an organized source that apt will understand. The groups of packages officially hosted by Ubuntu are categorized into four main categories. Main, which represents canonical supported, Canonical being the company that creates Ubuntu, free and open source software. Universe, which is community maintained free and open source software. Restricted, which is closed source drivers, such as like NVIDIA graphics drivers. And finally, Multiverse, which contains closed source software, for example, Discord. By default, apt is configured to pull software from each of these four official Ubuntu repositories. Obviously, this can be configured if you want to adjust your system policy. This is where the Software Properties GTK tool comes in. And I'm just going to go ahead and open it on my image as well. Software Properties GTK. And you should see it pop up just like this. Now, from here, we can configure what repositories you want to be able to download software from. Source code is unchecked by default because it contains sort of the source code for libraries and binaries, which is only really useful for developers who want to inspect it. Note that it's not necessarily considered insecure to have multiverse or restricted software set, even though it is proprietary or restricted by copyright or legal issues, because there's lots of useful and often company required software that goes in these repositories because they're closed source. However, because the software is not audited by Canonical, and the same thing goes for Universe, it is always a good practice to know exactly what software you have installed in your system and for what purpose. Alright, now just as there is for pretty much everything else on Linux, there is a corresponding configuration file that reflects the Ubuntu software tab of Software Properties GTK, and that is etc apt sources.list. So I'm going to go ahead and open that up on my image as well. I'll just X this out and open etc apt sources.list. Now, I'm actually just going to go back to my slideshow because I've made it a little bit prettier for you guys. So really what I've done here is blanked out all the lines that we're going to ignore, but let's just talk about this file in general. So the sources.list file contains a list of repositories from which updates and packages are sourced. Now, I recommend you open this file again on your virtual machine and check this out with me. Note that the lines starting with hashtags, which are the ones that we're going to ignore, are just considered comments that are not parsed by apt. They're just there to make parts of the file a bit clearer for us. So in my slide deck, I've just grayed them out to make it clear what lines are actually being read by apt. So let's break down the first line and understand how it corresponds to the graphical user interface we just saw through Software Properties GTK. Now, the first portion of the line, which is this one right here, deb, corresponds to the package type to download from the software repository. This can be either deb or deb-src, as you see in these comments, but deb-src is source code, and we don't have source code checked, nor do we really want it, so yeah, that's just the package type. Next is the URL for the HTTP server hosting the package repository. If you actually visit this link in your browser, which I'd encourage you to do, just pause the video and explore it real quick, then you'll see the file or the files containing all the packages that you can download. It's just a file server with all of the deb packages. Um, Now, next is the code name referring to the version of Ubuntu that you're downloading packages for. Each version of Ubuntu has like a code name corresponding to it, where like Ubuntu 22 is Jammy, this one is Ubuntu 20, and that would be Focal. There's also 18, which is Bionic, 16 is Xenial, 14 is Trusty, I believe, and it goes on. Really, you won't see any of those older versions. I've just been competing for a long time, so yeah, those are just some code names that you'll see pop up. And finally is the repository types you'd be able to download software updates from. And remember, we saw that on the last slide where we had main, universe, restricted, multiverse. We want the main and restricted repositories from this URL, and that corresponds to sort of where you want to download the updates from. Now, finally, you'll see some lines that show focal-updates, and this codename corresponds to packages released or package updates released after the initial release of Ubuntu 20. In this case, 20 is because it's Focal. If you had, for example, Bionic, it would be packages released after the initial release of Ubuntu 18. So yeah. Now, with that, I would like to mention that after each modification of this file, you'll need to run the apt update command. Now, if you modify the sources through software properties GTK, for example, if you went to software properties and you wanted to, I don't know, uncheck one of the repositories for some reason, then you would actually have to wait for this to load from our presentation. But you'll actually have to run the apt update command, or you won't have to run the apt update command if you do it through the graphical user interface, because the interface already does it for you. Now, this command updates what we call package lists on your computer, which contain a list of all the packages available from each software repository you've configured. If for some reason your sources.list file was misconfigured to exclude a certain package repository and you weren't able to download some packages, and say you've patched the issue by adding it back either through graphical user interface or through the file, you need to run the apt update command before you're able to install a software from the repository you added back. And the reason for this is because it needs to update the package lists that are local to your system. Now, not doing this is why a lot of people, especially in cybersecurity competitions, get stuck with package not found errors and they're not sure how to move forward. So just keep this in mind. It's super important. Make sure you run this before upgrades, before or after you change some package list configurations. So now that we have a clear understanding of apt and some software repositories, I want to address the other range of apt configuration under the etc apt directory, which you might have saw if you were poking around already. Now, the etc apt directory we can use to sort of harden, in a sense, the package manager. But before I go on, I want to briefly cover the concept of GPG keys. Now, this will be useful in just a sec, so just bear with me, and we'll go on to the next slide, and hopefully it'll make a little bit more sense on where this is applied. So a GPG key is a cryptographic key that allows someone to sign some sort of message so that the recipient knows that when they receive it, it hasn't been tampered with. You can think of GPG key signing as being a two-part process. Imagine I have a special stamp with my signature that I only own. If I wanted to send a message to my friend in a way that he knows nobody else has tampered with it, I could stamp an envelope containing the message, which with my private and special stamp that no one else has, to create a unique shape. Because my friend knows that this shape results from my particular stamp, he can verify that, all right, this envelope has not been messed with while it's been transported from myself or from Safin to me. Note that in this scenario, nobody else can replicate this stamp, but they all do know the unique shape that it generates corresponds to me. Now, this would be useful in the case that on a Linux system, a user wants to verify that a specific package they've received from a package source, whether that's the URL we checked out on the sources.list file earlier. They want to check whether that package has not been tampered with between the compilation process from when the code was compiled into an executable, all the way to the action of receiving that package from the software repository, which would prevent malware from being injected into the package. Now, apt requires that their packages are signed with keys, and external repositories often have their own special keys that you can add. So, now that we sort of understand what's going on with GPG keys, let's cover all the different ways to configure the apt package manager. And what I've done here is just showed you a directory tree of the etc app directory, and we'll go over each of the sort of files and folders step by step. Now, you'll see the sources.list and sources.list.d directories and files, which we already covered. So sources.list.d is just an extension of sources.list where you could have some extra files in the same format of sources.list. And they'll also be included by apt when determining what sources to pull updates or packages from. Note that you should always check this directory in case an attacker or someone has installed extra package repositories as a possible means of persistence. Apart from the sources, there's also let's go through each one step by step. Like I said, the first one will be apt.conf.d. Now, this directory contains just generic apt configuration files, some of which are configured by software properties GTK. Three files that I would highly emphasize and that are particularly important in a setting where regular updates and package maintenance are key, which is just about every single company scenario. 10 periodic, 20 auto upgrades, and 50 unattended upgrades. These three files, you can just open up any one of them and Google each preference to determine its function and optimal setting. I would highly recommend you literally go through every setting in each of these files and really go through them. A good rule of thumb, I would say, especially for cybersecurity competitions, is to keep your system up to date as often as possible, sometimes even sacrificing user experience to do so. For example, even though it might be impractical in a real company server setting, the ability to, for example, automatically download and install updates could possibly be important for your competition, so just be aware of that. Next, the auth.conf.d folder contains some credentials for authenticated repositories. This stores your username and password basically. For private repositories you've chosen to retrieve packages from, you can actually add private repositories. You just put the link and you will have to use a username and password to authenticate to it. This could be useful if your company has an internal repository containing company specific packages, but you won't really be interacting with it that much in the context of cybersecurity competitions. The keyrings and trusted.gpg.d folders contain the public GPG keys with which to verify packages installed by apt. You can think of it as sort of a database, like relating back to our stamp example. You could think of it as a database of all the stamp shapes and the names associated with them, so that you can ensure that the packages you receive have not been tampered with. So you can associate a stamp shape with the person who stamped it, just to ensure that it hasn't been tampered with. Finally, the preferences.d folder contains some extra package configurations that you can configure with the apt mark command. You won't usually configure this one manually, but it is worth taking a look at. Now, let's go a little bit more in depth into apt-mark because it is pretty important. So the apt-mark command allows you to set or unset preferences for individual packages. Now, what I mean by that is a package can be marked as being manually installed or automatically installed, which can be useful when scouting for unauthorized packages on a compromised system. Using the apt-mark show manual command, you can browse the list of packages that has been marked as manually installed by some user, which includes any potential attackers who could have installed malware. Note that this is not necessarily comprehensive because a manually installed package could be marked as automatically installed, but it is a rare occurrence, especially in cybersecurity competitions, although it would be an interesting persistence tactic. So just remember, apt-mark show manual can be very useful when searching for malware. Now, apt-mark also allows you to hold a package, which prevents it from being upgraded or uninstalled. This is useful in a company setting where service packages such as SSH should be fixed at a particular version so that no breaking changes are made to its configuration format, for example. You wouldn't want to update a program that your company relies on unless there's a significant bug fix, like a 0-day that was patched by the company that creates the software, because there's always a maintenance cost associated with upgrading software. Someone has to go into your server and update the configuration so that it works with the new version, and you have to pay that person. So obviously that's not something you really want to do. However, in the context of cybersecurity competition, apt-mark could be used to prevent someone from uninstalling malware. Now, if your strategy for removing malware is to just mass remove a huge list of packages, it's really, really easy to miss packages that are not being uninstalled. And I think it's a pretty good idea to check what packages are held on your system, as it can be an indicator of what packages to look into in particular. It's worth noting that there exists a separate concept of package pinning, which I've linked documentation to here, but won't cover in this presentation, just because it's less common. So, let's cover some common issues and nuances with apt. One concept that I and many other competitors are often stuck on is the concept of apt locks. Now, let's just run an experiment. Let's I encourage you to open up your virtual machine, and I'll do the same thing with you guys. Open up your virtual machine, and I'm just going to go ahead and open two terminals, just like this. And in one of them, I'll run apt install, oops, and make sure you use sudo for this, and then the name of some package. And then this one, I'll run the same thing, but a different package. Maybe I'll choose Apache 2. Now you'll see this error message, and I'm just going to go back to the presentation so you don't have to see this spam in my console, but it's really just the same thing here. You should get errors similar to this one on the slide. It should say something about could not get lock, but you might have seen this before, but let's just analyze what it really means. So remember that apt hands off packages to dpackage to unpack them and maybe run some scripts after dpackage installs it. And usually those scripts can modify parts of the file system by adding or removing files. Now, that doesn't seem like a big deal, but imagine you were trying to install two packages, package A and package B, where package A could be a standalone package that simply installs itself on the computer without any issues, but package B, after installing itself, might check whether package A is installed and performs a certain action and otherwise does not. Now, there could be an issue where if both installations were running at the same time, package B might not be able to deterministically know whether package A was truly installed in time and could result in undefined or incorrect behavior. Like, for example, if we were to try to install PAM and SSH at the same time, and the SSH installer needed to know whether PAM was currently installed, so that if PAM wasn't installed in time, SSH would not generate a PAM configuration for itself, but in the case that we were actually trying to install both, this would be incorrect behavior. It's not what we would have wanted. Now, in programming, the issue of program behavior, depending on the timing of other concurrent operations for correctness, is called a race condition. And we solve these race conditions with something called a lock. The way that locks work is that they allow us to ensure that only one resource is being accessed at a time. And apt utilizes these locks by creating a file to represent this lock whenever an apt command has been run. This file indicates to other concurrent, meaning other running apt processes at the same time, that apt is currently being sort of used and that it must wait in order to be executed. The install command, for example, creates a lock file, and it must or lock file to indicate that one apt process is already running. In this case, the apt install nginx package or process is already running. And the issue with this is that we need to wait for this lock to finish. However, sometimes we encounter this issue even when we haven't run two apt commands at once, and you might be a little bit confused why. This typically occurs when there is some background process using apt that's currently running or stuck, for example, like unattended upgrades, which might be upgrading your system in the background. That's why it's called unattended upgrades. And in this case, usually the best way to handle a lock is to simply wait for the process that's using it to finish. However, if you really need to kill that process because it might be hanging for some reason, you can use the kill command followed by the process ID associated with the other process using the lock, and that would be right here. If you see this 6472, if you go back to the image, it would be 6084. And you could kill that process, and it'll sort of get rid of that lock file, and you will be able to take back control of the current apt lock. But just do that with caution because you might be interrupting an installation or upgrade, so just be a little bit careful of that. And in the case that you do happen to interrupt it, that's where we'll encounter some issues regarding dependencies. And I want to talk quickly about dependencies and then conclude with some hardening tips. So one concept that's important to uninstall, or sorry, not uninstall, to understand is the idea of dependencies. Now, apt packages often depend on each other for functionality, just how apt depends on dpackage to work. If one of the dependencies of a package is not installed correctly or is broken, perhaps because you killed it while it was running, or maybe it simply just had an error, the package that depends on the other packages, might not work as expected. Now, if you encounter a broken package or dependency error, you can try reinstalling the package that you know is broken with apt install dash dash reinstall, and then the name of the package. And you can use the apt install -f command to automatically find and fix broken dependencies or packages on your system. And usually this is sort of just a debugging process, and you'll end up doing a lot of research and learn a lot. So if you do encounter this, don't be afraid. Try these two commands out, and if they don't work, just do some research based on the error messages that you are getting. Now, finally, if you're looking for more references on where to start configuring apps, I highly recommend, as always, the STIGs, Security Technical Implementation Guides that are released by DISA. And I've also linked some specific Debian documentation. This is for unattended upgrades on how to set them up and what the function is. And I highly recommend you look into that, especially in the context of a cybersecurity competition where keeping your software up to date is critical. Now, I'd also recommend, like I said, to look into these three files that I mentioned earlier. But yeah, I hope this presentation was helpful. As always, feel free to let me know if you have any questions in the comments, and comment on what you'd like to see next. I'd love to hear from you guys. So yeah, thank you guys.